Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're looking at the 2025 paper and it is question 3, part B. So an electrician needs to link 7 landline telephones in an office. The telephones A to G need to be connected by cables within the same electrical network. The table below shows the distance in meters between the different telephones, and we can see our two-way table there from nodes A to G. Part 1 then says the electrician wishes to use the minimum length of cable required to connect every telephone using the same electrical network. Starting at telephone A, use Prim's algorithm to calculate the minimum length of cable required. So Prim's algorithm works from a matrix, which this is. You can draw out the network, but that is going to waste time. So it is important that you know how to work from a matrix using Prim's algorithm. So here's our matrix. The question told us to start with node A, so let's label that 1. When we're working with the graph, one of the key rules when we're using prims and even crucicles is that we don't want any cycles. We don't want to end up back at a node we've already been at. That's a waste of an edge. It's not needed. So how we make sure that that doesn't happen when we work directly with the matrix is we ensure that when we get a node like here, number 1 for A, we cross off the row belonging to A. That means we'll never revisit it, which is really good for us because we can't visualize it in the same way. Once we have our first column marked, we then look within that column to find the smallest number. So the smallest edge there is our 9, which links to B. That makes B our second node. And again, to ensure we don't have a cycle, we want to cross off the rest of row B. Then we have 2 columns that we're looking at. So you're looking at everything in A and in B. Okay, it's not just going to be because that was our last one. Prims looks at all active nodes. So A and B are both active. So across those 2, the smallest number is 9. That links to F. That makes F node 3. And we cross off the rest of the row linking F. So then we have 3 columns. We have A, we have B, and we have F. So the smallest number across those 3 is actually the 8, which links to G, making G our 4th node. We now have 4 nodes. Up to now, our most recently marked node has always given us the smallest number. But here, if you look across our columns marked 1, 2, 3, and 4, our smallest number is actually 9, which exists in the third node, so in F. So it's this one here. So it's really important you're looking across all of those columns, not just the latest one. So that makes D our 5th node. So let's cross off the rest of the row for D. And now we have 5 active columns. So that gives us a 10, which is the smallest, which makes E our 6th node. Cross off the rest of E. And now we're just looking at how do we connect to C. So C will be connected with the smallest number, which is through D. That gives us an 11. That makes C node 7, and we cross off the rest of that row. So everything in a box there is one of our edges of our minimum spanning tree. So we need to make sure that we present this information in a way that will get us our marks within the exam. So we start with column 1 and we write down the edge. Remember when we're dealing with trees, it's different to how we deal with paths. So when we deal with trees, our tree, we have to do it in edges. So this will be A to B, and that is equal to 9. I have my 2 little lines there to say the length of AB is equal to 9. So then I move into column 2, and in column 2, I've B to F, which is also 9. Now, if you wrote that as F to B, not an issue at all. So then I go to column 3, which is F. I do F to D is 9, F to G is 8. Now, people might put that in a different order. Again, that's absolutely fine. There's nothing in column 4 because G doesn't connect onwards. It's only connected to F, and we already have that written down. So I move on to column 5. That gives me D to C, which is 11, and D to E, which is 10. There is nothing in 6 and nothing in 7. Count your boxes really quickly. I have 6 boxes highlighted in my matrix. There are 6 edges here. So that's always a nice double check because you don't want to lose anything while you're transcribing it. So then the total distance for our minimum spanning tree is going to be 56 meters. So like I said, you're welcome to draw out a diagram for this, but it can take longer. This is a very quick, efficient way that you can work in an exam if you have the matrix. So it then asks us to draw the electrical network that uses the minimum length of cables. That's the minimum spanning tree. Don't write the whole graph and then highlight the minimum spanning tree. That's a waste of your time and your energy. They literally just want what we have above. So we go A to B, B to F. F then has two connections. It goes to D and it goes to G. Then D connects to C and to E. No need to put your lengths on it. Absolutely can once those nodes are very clear. Just be very, very mindful that we do not have any arrows here. Our matrix, which I know is crossed off there, but if you look at your question, the matrix is symmetrical. That means that we have no direction, it's undirected, there should be no arrows drawn. Make sure your nodes are very clearly shown with a dot and that they are labeled. So part 3 then says, name another algorithm that could be used to calculate the minimum length of cable required. And the answer is Kruskal's algorithm. The difference is if we want to use Kruskal's, we would absolutely need a graph. Kruskal's does not work directly from the matrix. That is one thing Prim's has ahead of it. So we would have had to either be given the graph or draw out the graph and work from it there. Remember, for Kruskal's algorithm, our focus is not on nodes, but just on the next shortest length.